Okay, today we're going to start looking at chapter 4, which is all about the ways we do bonding. Section 1 is called ionic bonding. And the cool thing about ionic bonding is it always involves a metal ion and a non-metal ion. We call the metal ion the cation because it's going to give up its electrons, and we call the negative ion the anion because it's going to get extra ions. So atoms that have fewer than 4 valence electrons, they're going to transfer those electrons to other atoms. The general term ion just means an atom or group of atoms that has become electrically charged. You become electrically charged by giving up electrons or by taking electrons. So a cation is positively charged, meaning it lost electrons. So cations, I remember because cats positively purr. Okay? Anions, on the other hand, are negatively charged, meaning they have gained electrons. So an anion gets another electron. Hopefully that helps you. Okay, an ionic bond forms between two oppositely charged ions. So that means you have to have a positive ion and a negative ion. Now, there's a special rule called the octet rule, which says anything that has 3 or fewer valence electrons is going to lose their valence electrons. It's not an option. They will give them up. They do that because that outer energy level, which has those 1, 2, or 3, is kind of uneven. That outer energy level can hold up to 8 valence electrons. When you have 8 valence electrons, you are very stable. You're not going to bond with anything. So if you give up your 1, 2, or 3 valence electrons, now that outer energy level becomes empty and the energy level before it is full. Depending on where you are on the periodic table as an element will determine if that energy level before it will have 8 or 12 or 15 or 18 or 32 or any other weird number. So an octet rule says when you have 4, you're either going to gain or lose depending on what kind of element it is. If you have 5, 6, or 7, you're going to take the number of electrons you need to get to that magic number of 8. So if you have 5 valence electrons, you're going to take 3 valence electrons. 6 valence electrons, you're going to take 2 more. And if you have 7 valence electrons like the halogens, the group 17, they will take 1 more to get to that magic number of 8. You really need to understand this octet rule. Okay, so compounds are electrically neutral because their ion charges balance out. You have to remember that atoms are electrically neutral. Your number of protons tells you the atomic number for each element. That's the number of positive charges. Your number of electrons, that's the negative charges, will equal that to be a neutral atom. Well, when you become an ion, you either gained or lost electrons. So to get back to neutral, you create compounds. Polyatomic ions is made up of the word polyatomic, which means many atoms. That's all the word means. Polyatomic ions are many atoms working together but react as one ion, whether it's a positive ion like ammonium, NH4 with a +1 charge, or any of our other negative polyatomic ions that are on that polyatomic ion sheet. So the example in the book was the sulfate ion. It is created by 1 atom of sulfur and 4 atoms of oxygen. It's 5 atoms with 1 overall charge of a 2-, or you might see it written as a -2. Either way, it means those 5 atoms are working together and have 2 overall extra electrons. Okay, when we name ionic compounds, there's a couple rules to remember. Positive ion, that's your cation, always goes first. The negative ion always comes second. When we name them, the positive ion gets its full name. The negative ion, if it comes off the periodic table, meaning it's a binary compound, 2 elements off the periodic table, that ending for that name changes to IDE. If it's a polyatomic, you leave the name alone, just like it's written on your polyatomic sheet. So for example, if I have calcium and I have it bond with fluorine, calcium has a 2+ charge because it has 2 valence electrons and because it's a group 2 element. So calcium gets its full name. Fluorine is a group 17 halogen. It has 7 valence electrons, so it's a negative ion, so it's going to take those. To balance it out, I'm going to have calcium fluoride. There's going to be 2 fluorines to make the compound, so I would write it as CaF2. To name it calcium, the positive ion goes first, so it gets its full name, calcium. Fluorine, the negative ion, the one that took the electrons, its ending, I'm going to take off the INE, I'm going to keep that fluor part, and I'm going to end in IDE, so fluoride. All right, the properties of ionic compounds are going to be very similar to the properties of metals. They're going to have a crystal shape, they're going to have a high melting point, and they're going to be able to conduct electricity. The reason being, the ions can make electrons move between things. So every ionic compound has some sort of crystal shape. They're all going to have a high melting point, sort of like our sodium chloride, which reaches a temperature of 801 degrees Celsius before it changes to a liquid. And then electrical conductivity means when it's dissolved in water, they break into their ions. So you have positive ions and negative ions in the water, and that will allow electrons to move between, which is what electricity is. But remember, it's because they dissolved in water. When they are solid compounds, they do not conduct electricity. So you can't just put a bunch of table salt in your battery compartment and make something run. The salt has to be dissolved in water, and then it acts as a conduit to have the electrons move between and conduct electricity. All right, review questions for section 1. The question was asking is how is an ion formed? And remember that when I write my responses, I put part of the question in my answer. So I know that an ion is formed by gaining or losing electrons. So the second question asks, well, what were the properties to identify an ionic compound? And I know they are the crystal shape, high melting point, and electrical conductivity. Question 3 was asking how are ions attracted to each other, and it's because of their opposite charges, positive and negatives. Question 4 gave you a bunch of compounds and you had to name them based on the elements in there. So the first one was sodium fluoride, NaF, beryllium iodide, BeI2, potassium sulfate, K2SO4, calcium oxide, CaO, hydrogen sulfide, H2S, and magnesium carbonate, MgCO3. Question 5 was asking, well, what allows the ions to move so freely? And it's the water breaking the compound, helping to dissolve them into their ions. And then the 6th question, they gave you scandium with a 3+ charge and iodine with a 1- charge, and you needed to crisscross to create scandium iodide.